Our next layer is going to be our layer 3, known as our network layer. Now, our network layer is commonly referred to as our IP layer because this is where we're going to be using IP addresses. Now, when we talked about our layer 2, we mentioned MAC addresses. We talked about how MAC addresses are unique addresses for our individual network interface card, and these unique addresses are point to point. When we're sending on our data link layer, when we're sending on our layer 2, we're sending data point to point directly to a single MAC address. When we're sending through layer 3, we're also sending to a single point, but layer 3 is going to allow us to actually take that data and route it over different networks. IP addresses are logical addresses. They're not physical addresses hard-coded into our network interface cards. If we want to set one computer a certain IP address one day and then change it to a completely different computer an hour later, we can do that. They're logical addresses. They're not hard-coded. So we're taking another step up, even more away from our physical layer. So at our layer 3, we're going to translate our logical addresses, our IP addresses, to the physical addresses, such as our MAC addresses on our layer 2, our data link layer. All of our computers with a network interface card have a MAC address, and they also have an IP address. And you ask, well, why do we need both? Why can't we just use MAC addresses everywhere and just send data directly to a single computer in the world? Well, that would be globally unique IP version 6 IP addresses that are being developed, but we will talk about those a little bit later. But transferring data through MAC addresses over a global scale is a little bit infeasible with the way we currently have networks set up. We need to be able to take a computer's MAC address, assign a particular IP address to that MAC address, and then route data through MAC addresses over our networks. We'll do a diagram in a little bit, but let's go ahead and finish our points we have here. So we talked about referring to our network layer as an IP layer. We talked about our network layer, well, we didn't talk about our network layer being a functional means of transferring data through one or more networks. If we have a MAC address and we're trying to transmit data to a computer on a different network, a computer in a different subnet, we can't transmit data to that computer by its MAC address. We need to use an IP address because between us and the computer on that other network, we have to go through a router, and a router needs to have an IP address that it can use in order to transmit information. So this layer 3 is going to be where we're transmitting our data into different networks. We are going to be performing network routing functions. Layer 3 is going to do where we encounter fragmentation and reassembly of our different packets. And we have our routers at layer 3. Our routers are going to be performing these network functions. They're going to be taking packets, looking at the IP addresses, and sending them to their particular destinations or their particular, knowing where they came from, rather. I promised you guys a little bit of a diagram to help explain this a little bit better. So let's take a look. Let's talk about the layers that we've hit so far. Now understand in this diagram, we're going to be omitting our layers 4, 5, 6, and 7, just for simplicity's sake. But in order to get a better understanding of these layers 1, 2, and 3, let's go ahead and draw them out. If we have computer A here, and computer A needs to send a data packet, well, computer A is going to take the data that it needs to send. It's going to take the packets that it needs to send, and it's going to break them down into data that can be transported over physical means. So it's going to break them down into electrical impulses. These electrical impulses are then going to be sent out over our network interface card over a cable. All of these parts of our network connectivity, all of these cables, all of these bits, and all of these electrical impulses are going to be layer 1, the physical layer. If you hear someone referring to an issue as a layer 1 issue, that means that there's a problem somewhere between point A and point B with the physical connections. So again, we mentioned earlier how the OSI model can help us with troubleshooting. It can help us to identify where the issue is going on, where the issue is in our transportation between one point and another point. So we have our physical layer and we say, oh no, we have a layer 1 issue. Well, because we know the OSI model and we know that layer 1 is our physical layer, we know, okay, we're having a layer 1 issue. That means there's something wrong with the physical connection. Maybe we had a cable that was cut by accident. Maybe our network interface card burned out, or maybe it was ripped out of the socket. Maybe our pins are bent. Those are all layer 1 physical issues. So we have our electrical impulses inside our computer to our network interface card to our cable. Well, this network interface card has a unique address. We talked about the MAC address. That sending MAC address is going to be it may be written on our network interface card, but it's a unique address that's assigned to that computer, a unique physical address assigned to that particular MAC, or to that particular network interface card, and that MAC address is going to be layer 2. So we have our MAC address, we have our data link layer, and if we were sending this data packet directly to computer B, to its network interface card, directly to its MAC address, that would be the layer 2 point as well, because it's the data link layer. It's that unique point-to-point connection. But we can't do that. This computer B is on a different network than us. Maybe it's in a different building, maybe it's down the hall, but whatever the case is, it's on a different subnet than us. So because we need to connect to this over a different network, we have a layer 3 device in between us and this other computer. At least maybe we have a couple of these different devices. So on our side, we have a router, and then some cable connections through our building. And then there's also a router on this other network. So for simplicity's sake, we're just going to assign everything one IP address. Routers will have 2 IP addresses in our actual networks because they'll have an IP address that faces us, and then they'll have an IP address that faces outward. And then the same with our other router, it would also have 2 IP addresses. But just for simplicity's sake, we're going to put our IP address, just a single IP address, in order to identify our network. So now we need to throw our layer 3 in here. We can't use our data link layer and just send over layer 2 from MAC address to MAC address. So we need to put our 3rd layer in here. Our layer 3, our network layer, we're going to have IP addresses on computer A. This is going to be 192.168.1.15. Our router is going to be 192.168.1.1, and that's our network A router. Our network B router is going to have the IP address of 10.0.0.1, and our computer B is going to have the IP address of 10.0.0.17. These IP addresses are on different networks, so our computer needs to go through the router. So we have our data that we took and we made into bits. We then took those bits and we made them into frames on our layer 2. So what do we have now? We need to package that data up so we can send it across our network. Our layer 3, we're going to have packets. So we've now taken that data, we've taken those frames, we've started to network them, we've given it IP addresses, and we now have packets. We're going to take those packets and we're going to send them to our router, which is a layer 3 device. A router is a layer 3 device. And our router is going to take that data and it's going to route it to our separate network here, and then it's going to allow it to connect to our computer. Once that data gets to the point where it's now sending directly to the MAC address and it's now going directly to that single computer, now we're back at our layer 2 again because we're sending directly to the MAC address. And then once that data is back in our network interface card and being transmitted back to electrical signals, we're back at our layer 1 again. We're back at our physical layer. So at any given point in our connection between computer A and computer B, we have all 3 of these layers sort of performing at the same time. Our electrical signals don't stop at computer A when they leave our computer. We have electrical signals going on between our 2 routers. So we still have layer 1 connectivity going on. When we are transmitting data and we are using, when we're transmitting between our router and our computer B, we have layer 2, we have data links going on. And when we are transferring between our router 2 and our computer B, we still have those physical layers going on. So all 3 layers are working together and they're building on top of each other in order to provide connectivity. When we are discussing and we are trying to troubleshoot issues and we say that we're having layer 1 connectivity, we're having layer 1 issues between the 2 routers, maybe a cable got cut, and so we consider that a layer 1 issue because everything is correct with our data link and everything's correct with our IP addresses and our network layer, but the issue is at our layer 1, the issues with the physical connection. So this is one of our ways that we can understand how layer 3 works. Again, we are omitting a lot of steps, we're omitting a lot of details with this connection that's going on here, but the big things to remember with our layer 3, our network layer, is that this is going to be also referred to as our IP layer. This is where we're going to be transmitting data to one or to more than one networks, and this is also going to be where our routers are functioning at our network layer.